Welcome to today's AI engineering class. In this explainer, we're taking a crystal clear look at one of Python's absolute most foundational concepts, data types. If you're going to build an AI application, or really any software at all, you really have to know how your program stores and understands information. So let's break this down visually so it just clicks right into place. Here's our quick roadmap for today. 1. A Python basics recap. 2. The container metaphor. 3. Strings, which store text. 4. Numbers, specifically integers and floats. 5. Booleans, representing true or false. And 6. A handy data type summary table. Section 1. Python Basics Recap. So, if you recall from our last session, we really leaned on two crucial tools. First step is the print command. That's simply how we get Python to display our output on the screen. Second are variables. Think of variables as these blank containers that just sit there and store information for us to use later on. Printing and containers, those are the exact building blocks we're going to expand on right now.
Section 2. The container metaphor. To really get this, we have to ask a fundamental question. What exactly is a data type? We talk about giving Python all this information, but how does it actually organize it? How does the computer know the difference between a word, a number, or a logical choice?
Well, the answer lies in a really simple metaphor. If a variable is just an everyday container, a data type is basically a label that tells Python exactly what specific kind of container it needs to be. Think of it like your kitchen, right? You wouldn't pour hot soup into a cardboard box. Python works the exact same way. It needs specific, purpose-built containers for numbers, completely different ones for words, and totally separate ones for true or false answers.
Section 3. Strings, storing text. Let's see how strings, abbreviated in Python as just str, actually work. It's a super simple 3-step process. In step 1, we create a variable. Let's call it name, and we assign it a text value using quotation marks, like favor. Now, those quotation marks are the golden rule here. They're literally what tell Python, hey, this is a string. You could also do this with a variable like food and set it to rice. Then, step 2, we give the command print name. And finally, in step 3, Python outputs exactly what's inside those quotes, favor. It's that clean and that simple.
Section 4. Numbers, integers, and floats. Okay, moving on to numbers. The first number container is called an integer, or int. Now, an integer is strictly a whole number container. Absolutely no decimal points allowed here. So, step 1, we assign a whole number, like age equals 20. Step 2, we tell Python to print age, and step 3, Python outputs the integer 20. Notice, no quotes needed here at all, just the pure number. But, as we all know, the real world isn't just whole numbers, right? While we use integers for whole numbers like 20, Python needs a totally separate container for precision, and that is where the float comes in. Floats are containers specifically designed for numbers with decimal points. So if you're tracking a height of 1.65 meters or maybe a price tag of 2500.50, an integer container would just drop that decimal entirely. A float, on the other hand, perfectly preserves that exact fractional data. Let's walk through the execution of a float variable so you can see it in action. Step 1, we assign our decimal value. Height equals 1.65. Step 2, we issue the command print height. And step 3, Python outputs exactly what we entered, 1.65. Assignment, command, output. Once you get a feel for this pattern, the logic becomes incredibly predictable. Section 5, Booleans, true or false. Now for the logic. The crucial point about this specific container is that it is completely binary. Unlike strings that can hold practically any text or numbers that can go to infinity, a Boolean or a bool only ever holds one of two states, true or false. And a quick tip here, note the capital T and capital F. Python actually expects that exact capitalization to recognize it as a Boolean. Think of it as the ultimate yes or no switch for your code. Let's look at how we actually store these logical facts. Step 1, we assign a logical state to our variable. We write is_student equals true. You could also write something like is_raining equals false. Step 2, we give the print is_student command. And in step 3, Python prints that exact logical state, true. As you progress in your AI engineering journey, your programs are going to rely heavily on these true or false containers to decide whether to run a specific piece of logic or just skip it entirely. Section 6, Data Types Summary Table. All right, let's bring it all together. Here is our summary table. We've got strings for text enclosed in quotes, integers for whole numbers, floats for precise decimal numbers,
and Booleans for your true or false logic. I highly recommend taking a quick screenshot of this right now. Keeping this exact structure in mind is going to make writing complex code so much easier. So, if variables are just containers, what amazing AI tools are you going to build when you start combining text, numbers, and logic? Well, up until now, our programs have only displayed information, but the real magic happens when we make them interact with users. And that leads us perfectly into our next big concept, the input function. The input function actually asks the user to type something. So instead of hard coding a name,